Hello, math students. Welcome back to our module on percents and proportional relationships. The name of this lesson is Part of a Whole as a Percent, and this is lesson 5. The goal for our lesson today is, today we will practice working with the part equals percent of whole. Okay, part equals percent of whole formula. Okay, the question that I want you to think about is, how do you identify each part of the math sentence to use the formula? So this formula is actually really, really important, kiddos, and it's one of those that I would like you to start just trying to get memorized into your brain, because throughout the rest of this module, this formula is going to make everything make sense. So if we can start working on, remember that, P equals percent of whole, that's another way I remember it, part equals percent of whole, P equals percent of W, however you want to remember it, we've got to start remembering that one. Okay, the question is, how do you identify each part of a math sentence to use the formula? We're going to go over that together. All right, so in the things to know section, part of a whole percent problems involve a comparison of numbers and a comparison of a quantity that is a part of another quantity. Okay, and that gives you an idea, because when it says part of a whole, that means we're working with a whole amount, but you only know part of it. Okay, and so the best way to understand this and to figure this out is to use visual models to help you solve the problems. The visual models that are really helpful with this lesson is the use of a tape diagram, the use of a double number line, and the use of equations. I'm pretty sure you're very familiar with tape diagrams, I know you're working on your knowledge of equations, and then the double number line was actually something that you should have been introduced in 6th grade, so I'll go over that briefly to make sure you've got that one. I like this one the best when we're working with these problems, because it's a really great visual tool that helps us see. All right, so the next thing, really quickly, just in case it's new to you, remember these right here are tape diagrams. So you take a piece of tape and you split it up into as many sections as you need. So that would be a tape diagram. The double number line, just as a visual reminder, is you actually have two number lines that sit on top of each other, and they share values of whatever you identify them. So you'll name this top number line something, and you'll name this bottom number line something else. And then the numbers sit across from each other because they're equivalent to each other. And then equations, the equation obviously that we're working with in this one is you're working with the equation part equals percent times whole. That's the equation that we're working with in these. All right, so it says on here that we would like to give it a try. So it says, let's try it. On a recent survey, 60% of those surveyed indicated that they prefer walking to running. If 540 people preferred walking, how many were surveyed? How many preferred running? Okay, so we've got a lot of information going on in here, and one of the things we have to go back to up here is to remember that part of a whole percent problems involve a comparison of numbers, which we actually had in here, and a comparison of a quantity that is part of another quantity. Okay, so we read it once. We're talking about a survey. The survey was about walking and running, and now we've got to go back and read it again so that we can understand the quantities. On a recent survey, 60% of those surveyed indicated that they preferred walking to running. If 540 people preferred walking, how many were surveyed in total? How many preferred running? Okay, so what we're missing is we don't know what the total is, right? And then we also don't know how many were running, but we can figure it out by using all three of these models right here. And so what we're comparing is we're comparing the number of people walking to the number of people running. That's what we're comparing. And then we're also comparing the number of people walking to the total number surveyed, because we want to know both of those things. The part that helps us is they tell us that 60% of all surveyed preferred walking, and then they also gave us that 540 people preferred walking. So we just found out that 60% is the same as 540. So that was really helpful in reading. So what I would like to do is I would like to use all three models to show you how simple this is. So when we're using the tape diagram method, what we need to figure out is the size of our tape. And the things that we have to do is we have to be very careful how we label it. So we have a tape here, and we know that the total part, if I was to put a bracket right here, this whole thing would be total surveyed. That's what this section up here is, because we're talking about all the people who took the survey. All right, then the parts that make it up have to be the number of people walking and the number of people running. Okay, so when we're talking about two things that we're comparing, we have to make this tape so that it is showing all of the data. So one of the things that I like to do is I like to remember that this says 60% of those surveyed indicated that they preferred walking. Well, I know just from my experience with percentages that 60% is bigger than 50%, and 50% is half. So if I look at my tape and I divide it a little bit more than half, because half would be about right here, but if I go a little bit more than half, like that, then I can say this right here would be my walking. And the reason that I know that that's my walking is because it said 60% was walking, so it needs to be a little bit bigger than half. So that's 60%. Well, if that's walking, then that means that this section over here would be the people who like running. Okay, do you see how the tape diagram is really, really helpful in figuring it out? Now, the other thing that we have to remember is they said that the people that liked walking were 540. So I'm going to go ahead and tell you that this section is 540. Okay, now this is where it can get kind of tricky because we are supposed to figure out the total, which we don't know, and we're supposed to figure out the number of running, which we don't know. But what we do know is that this chunk right here is 60%. So if I have 60% right here, I'm thinking that I could break this into 6 equal pieces, right? And then if this is 60 right here, what does this have to be? Because remember, the whole thing always, whenever you have an entire thing, that represents 100%, right? So if this is 60% here, what does this have to be here? And if you're saying 40, then you're right, because 60% plus 40% equals 100%. So again, going back to what we were thinking, if I break this piece of the tape into 6 equal pieces, right, because it's 60%, then that's what it would look like, right? And then if I broke this into 4 equal pieces, because you said that that would be 40%, then that's what it would look like. So now I've got to think logically, do some math in your head. If this whole purple section is 540, and I have 1, 2, 3, 4, 5, 6 sections, then what I'd have to do is I would have to take 540 and divide it into 6 equal sections. And if I know my math facts, well, I'm recognizing right here that 54 divided by 6 equals 9, but it's not 54, it's 540, so it would be 90 in each. So in each section, I have 90, okay? So I have 90, 90, and 90, right? And then one thing that you know about a tape diagram is that if these are all 90, what do these all have to be? And if you said they have to be 90, you're right. So then these are all 90, because that's the beautiful thing about a tape diagram is once you know what each section is, it's that all the way across, no matter what we're talking about, whether we're talking about walkers, whether we're talking about runners. The minute you figure out what the size of each section is, it goes all the way across because count. What do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so if we have 90 in each one, then we've now got 100%. And now, just by looking at it, we have figured out our answer. So the total surveyed is, we have 90 in each section, we have 10 sections, so that means in order to get the total, we have to take 90 10 times, right? So 0, 0, 0, 9, and when you add that together, what do you get? 900. So the total number surveyed is 900. Okay, so that's pretty awesome. And then the other thing that we already know is that this is running from here to here. So that means I have 1, 2, 3, 4 90s this time. So all I have to do is 90 times 4, and I get 360. So now I figured it out that my walkers, because it gave it to us, right? My walkers are 540. My runners are 360. And then if I add those two together, and I will get, when I add them together, 0 plus 0 is 0, 6 plus 4 is 10, regroup the 1, 5 plus 3 is 8, plus 1 more is 9. So the total is 900. And I figured all of that out by using a tape diagram. So that's pretty cool. All right, the next thing that it said that you can use to figure these out is a double number line. The double number line is awesome. And the reason why it's awesome is because it does all of this that we had to do just on a quick number line. So I'm going to show you. Here's the double number line. Remember, I told you it's two number lines that we use together. And for me, what I always do is I always put the percent on the top line, and I always put the number of items down on the bottom. So I would say total surveyed, because that's what we're looking for, is the people surveyed, right? Okay, so now here's how it goes fast. We always know that over here starts with 0. So 0% and 0 people surveyed. Because if you have 0%, then you have nothing, right? So no people. Then the other one that I like to do very quickly is say, okay, well, on a number line, I need to have a starting point and a stopping point, and my stopping point for this lesson is 100%, because that's what I'm trying to find, because I'm trying to find a total. So 100% would be at the end. And then I've got to figure out what that number is, and right now I don't know, but if I go back into the story, it says that 60% preferred walking and 540 people are walkers. So you can see very quickly that 60% is more than half. So here would be half. So I'm going to go just after that and say that 60% is here, right? And I learned from the story that 60% means 540 people. And now all I have to do is figure out how to get to 100. So a very easy way to do it would be to backtrack and go, okay, well, I can get to 10% very easily by dividing 60 divided by 6. So I'm going to divide this side by 6, and what you do to one side, you have to do to the other. 60 divided by 6 gives me 10%, which is what I'm looking for, and 540 divided by 6 is 90. So now I know that 10% is 90, and I'm trying to get to 100, and I know the rule to get from 10 to 100, I have to multiply by 10. What you do to one side, you have to do to the other, so multiply by 10, and 10 times 10 is 100, and 90 times 10 is 900. And boom, you're done. You found the total, which is 900. You found the walkers, which was 540. And you found the runners. Oh, we didn't find the runners. I'm sorry. The runners is what we had left undiscovered. So the runners are actually at 40%, so we're going to say 40% is here. Very easy to find. How do you get from 10 to 40? You have to times 4. What you do to both one side, you have to do to the other. 90 times 4 is 360, and there are my runners. So again, the double number line is another model that helps you find them. Total, walkers, runners. There they are, and it's all on that double number line. So that's pretty cool. All right, the last way that we are going to solve this problem, and it's kind of funny because now we already know the answers, but it will help us understand how to use the equation. We're going to use the equation, and the equation that they're talking about is the part equals the percent times the whole, okay? And unfortunately, we don't know the whole because that's what we're supposed to find. Remember, the whole would be the total, but we don't know it. But we do know the percent, and the percent that we know is 60, because it says it right there in the story. So we do know that the percent is 60%, okay? We don't know the whole, so I'm actually going to leave that as W for the whole because we have to have a variable, and that's how you find the variable. But we do know the part because the part is the 60%. And we already figured out that 60% is 540. So the part that we're looking for is 540. So we're going to write 540 right here. Okay, so now this is a BU chart. However, pause for just a second. When you are working with percents, you actually cannot do anything as long as that symbol is in there. So that symbol is kind of a pain in the patootie. So what I like to do always whenever I see that sign is I'm actually going to turn it into a fraction, which we know is 60 hundredths, right? Because the percent symbol tells you per 100. The number in front of it tells you the number. So now I have 60 hundredths, and I'm going to say 60 hundredths times what number, right, equals 540. And that's what we're trying to figure out. And now, kiddos, you can use a BU chart to help you. All right, so using the BU chart, here we go. My build side and my undo side. My build side, what is my variable? W. What did I do to W? I multiplied it by 60 hundredths. So to undo that, I'm going to multiply by the reciprocal. Remember, because multiplying by the reciprocal is the same as dividing by the number. So multiply by the reciprocal, that means I'm going to multiply by 160ths, and that should give me W. Okay, so let's try it. If I take this and multiply it by 160ths, then I would get 6,000, right? And I would get 6,000 W. And then 6,000 divided by 6,000 is 1, which is times W, and 1 times W is W. Wow, that wasn't so difficult. Then I have to put an equal sign, and what you do to one side, here's what I did, I must do to the other, so change that to a fraction, and put 160ths on this side, and 60 times 1 is 60, and then 540 times 100 is 0, 0, 0, placeholder 0, 0, 0, placeholder 0, 4, 5, and I get 0, 0, 0, 4, 5, and I get that big giant number, which is 54,000, and then I'm going to divide by 10 by doing that, and then 6 goes into 5,400. Well, let's do the math because you guys are just learning. So 5,400 divided by 6. 6 goes into 54,9. That 0 goes into 0, 0 times. That 0 goes into 0, 0 times. And, boys and girls, look what you just found. The whole of this equation is 900. So I know the whole is 900, which is what we found as our total. I know that the part is 540, which is what we see right here, and 60% shows us there. So we were able to figure that out. So if we know that the whole or the total is 900, we know that the walkers are 540, then the last step when using your equation, all you have to do is subtract the total and the walkers, and that would give you the runners. So I have 900 minus 540, and I get 0. Make that an 8, regroup, that becomes a 6, and that becomes 360, which is what we were looking for before. Okay? So, lots of different models for solving all of the same problem, and there you go. I know it's a lot of information. I know that we need to have plenty of time to work on this, but kiddos, this is actually really easy if you can wrap your mind around it. Okay, kiddos, let's go back to our goal. Sorry. Today we will practice working with part equals percent times whole formula. How do you identify each part of the math sentence to use the formula? Basically, you've just got to look for context clues. You've got to figure it out. If it has a percent sign by it, then it's obviously the percent. If it's asking what the total is, then you have to leave it as you don't know. And then if it gives you a number, it's telling you the part. So again, it's just practice. Okay, that's all I have for you in this lesson. Talk to you soon. Bye.